Welcome back, everybody. Let's talk about balancing redox equations in basic solution. Our process for balancing in basic solution is going to look very, very similar to balancing in acidic solution. We're actually going to start and do the whole process just like we would for acid. But if you're actually in a basic solution, you don't have extra hydrogen ions. So once you've balanced your reactions, you are going to add hydroxide ions to both sides because that's what you have more of in a basic solution in order to eliminate the hydrogen ions. Where you have both hydroxide and hydrogen ions, you'll make water. And then you're going to have excess hydroxide on the opposite side of the equation. I'll show you how this works. And then once you've done that, you will form water out of any hydrogen and hydroxide that are on the same side of the equation. Cancel out any chemical species that are on both sides. Often you'll have water on both sides of the equation as a result of having hydroxide been added to reflect the fact that you're actually in a basic solution. Let me show you how this works with an example. Interestingly, if you take permanganate and you react it in basic solution, you get a different product than you would if you were in acidic solution. When you take permanganate ions and you react them in a basic solution, you get the compound MnO2, so manganese 4 oxide. So here's my overall reaction. In this case, I'm reacting the permanganate ion with iodide, and I'm forming the manganese 4 oxide and iodine. Just like we did before, we're going to start by determining what's being oxidized and what's being reduced by writing oxidation numbers. When we write those oxidation numbers, we'll see that the manganese is being reduced from +7 to +4, and the iodide is being oxidized from an oxidation number of -1 to 0. That allows us to write our two half reactions, one for reduction and one for oxidation, just as we did before. And then we're going to balance these half reactions exactly as we did before. So we're going to check, starting with our manganese reduction half reaction here. Check the manganese. It's good, one on each side. We're going to balance the oxygens by adding water, balance the hydrogens by adding hydrogen ions, and then balance the charge by adding electrons. In this case, we needed to add 3 electrons because when we began, the left side of this equation had an overall charge of +3 and the right side had a charge of 0. So we need to add 3 electrons to that left side. The reduction half reaction is now balanced, so we'll go to the oxidation half reaction, balancing the iodine by adding a coefficient of 2 in front of the I-, and then balancing the charge by adding 2 electrons to the product side. We can then add our equations. And just as we did before, you have to make sure that you've got the same number of electrons being gained and lost in these processes. And so we're going to need to multiply these equations. We'll need to multiply the top equation by 2 and the bottom equation by 3 so that we have 6 electrons being gained and 6 electrons being lost. And then we are going to take account for what we have for our reactants and products from that process once we add them together. And at this point, I'm going to make a note that the electrons can be canceled out because they're present on both sides of the equation. This is exactly what we did before. Now here's where the base part comes in. If you look, we have 8 hydrogen ions on the left side of the equation. If you are in basic solution, you have more hydroxide than you have hydronium ions. So that's not realistic. What we're going to do is we're going to add, in this case, 8 hydroxides to the left side and the right side. You'll add the same number of hydroxides as you have hydrogen ions. And you have to add it to both sides of the equation so you don't mess up the balancing. So I'm going to add 8 hydroxide to the left and 8 hydroxide to the right. And then I'm going to look, and if I have both hydroxide and hydrogen ions, those would combine to form water. And so I'm going to rewrite this equation showing water where it exists. And now we're almost done. I have 4 waters on the right and 8 waters on the left. I can cancel 4 of those waters out. And that leaves us with an overall balanced equation of 2 permanganate plus 4 waters and 6 iodide ions, forming 2 manganese 4 oxides and 3 I2s. Done. So balancing in basic solution is exactly like balancing in acidic solution, but towards the end, after you've balanced your equation, you need to stop and recognize you don't have H+ ions if you're in basic solution. Instead, you will figure out how many H+ ions you have. You will add that many hydroxides to both sides of the equation. Where you have both hydrogen and hydroxide, you'll combine them to form water, cancel any waters around both sides of the equation, and you're done.